Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to learn about solution of system of linear equations by direct methods. And this is the first lecture of 7th week for the course Numerical Analysis. Dear students, you have already learned about linear equations, system of linear equations and its solution in the course Applied Linear Algebra. In this numerical analysis course, today we are going to learn about two methods like Gaussian elimination method and Gauss-JORDAN elimination method. These two methods called direct methods. Why these two methods called direct methods? Because by these two methods we obtain exact solution of system of linear equations, and later on we will discuss some other indirect methods by which we can obtain an approximate solution of system of linear equations. The procedure for the solution of system of linear equations by Gauss elimination method. Gauss elimination method or Gaussian elimination method. The procedure for the solution of system of linear equation by Gaussian elimination method is, first of all, write the given system of linear equation in matrix form, and then write the augmented matrix of a system of equations. And secondly, convert the augmented matrix to row echelon form. And third step, write the system of equation again from the row echelon matrix. And at the end, using back substitution, find the value of unknown variables which appears in the given system of linear equations. For example, we have a system of 3 equations and 3 unknown. This is a system of 3 equations, system of non-linear equation. There are three linear equations, system of linear equations. So first of all, write this system of linear equation in matrix form, and then the augmented matrix displays the coefficients of the variables in an additional column for the constant. Then take the augmented matrix from this matrix system. This is the augmented matrix. The augmented matrix displays the coefficients of the variables and an additional column for the constant. These are the constant of the equation which lies in the right hand sides of the system, and these are the coefficients. This is the coefficient matrix and this is the constant matrix of constants. So combine these two matrices called augmented matrix. Now use row echelon form. Convert this augmented matrix to the row echelon form. For row echelon form, perform row operations on augmented matrix and convert it into row echelon form, in which there are ones down the main diagonal from the upper left corner to the lower right corner, and zeros in every position below the main diagonal as shown here. So in the echelon form, number of zeros will be increased row by row from the first non-zero entry. So here is 1 0, in the second row there is 1 0, but in the third row there are 2 zeros. So number of zeros will be increased row by row from the first entry. So Then system of equation again from the row echelon form. So at the end, when we obtain a row echelon form, then write again this matrix in equation form. We obtain three equations in which we get the value of z from this equation by using back substitution. So using back substitution, putting the value, obtain the value of z, and putting the value of z from for y, and then put the value of y and z for the value of x. So this is the back substitutions. For the back substitutions, solve this system. Find the value of z from equation number 3, and then put the value of z in this equation number 2 and evaluate y. Find the value of y, and then put the value of y and z and this equation number 1, obtain the value of x. So dear students, this is the procedure for the Gauss elimination method. How we can use Gauss elimination method, I want to tell you again. First of all, write, this is the given system. First of all, write the given system of linear equation in matrix form, and then take the augmented matrix. Augmented matrix contain two matrices. One matrix will be the coefficient matrix, and other matrix is the constant matrix, matrix of constant, which lies in the right hand side of the system. And at the second stage, convert this augmented matrix to the row echelon form by performing row operations. And when we obtain the row echelon form, then write this matrix form again in the equation form, and you will get equation number 1, equation number 2, and equation number 3 from the row echelon matrix. And using back substitution, first of all, find the value of z from the last equation number 3, and then putting this value of z in equation number 2, we obtain the value of y, and then putting the value of z, y and z in first equation, we will obtain the value of x. So dear students, but know that since I have already told you in the previous lecture that the solution set of linear system has three possible outcomes, and we can identify these three outcomes by observing the rank in the echelon form. When we obtain the echelon form from the augmented matrix, this is the echelon form of this augmented matrix. So when we obtain the echelon form of the augmented matrix, then identify whether the system has unique solution, system has no solution, or system has infinite many solution. So how we can identify these three outcomes for the solutions? Check, use the rank. If the rank of matrix A is equal to the rank of augmented matrix AB in the echelon form is equal to the number of unknowns. When we obtain the row echelon form, then check the rank of this matrix A. What is the rank of matrix? The number of non-zero row in the echelon form of a matrix is called rank of a matrix. So when we obtain echelon form of the augmented matrix, then use the rank and identify the case for the solution of system of linear equation. So in echelon form, when rank of matrix A is equal to rank of augmented matrix AB and equal to the number of unknown, then the system has unique solution. System has unique solution if rank of matrix A is equal to rank of augmented matrix is equal to number of unknown, then the system has unique solution. So dear students, this is the echelon form. In this echelon form, this is the matrix A, and this full matrix is the augmented matrix. So here the rank of A is 3, and the rank of the full matrix is also 3, and there are 3 unknown in the given system. For example, we have in this system we have 3 unknown. This is the x unknown, y unknown, and z unknown, 3 unknown. So when we obtain the echelon form from the augmented matrix, then check the rank of the matrix A and the rank of the full augmented matrix. If the rank of this matrix A is equal to the rank of augmented matrix and equal to the number of unknown, then the system has unique solution. And if rank of A is equal to rank of augmented matrix, but rank of augmented matrix less than number of unknowns, then system has so many solutions. And if rank of matrix A less than rank of augmented matrix and the rank of augmented matrix is equal to the number of unknown, then the system has no solution. So in short, procedure for the Gaussian elimination method, dear students, note that Gaussian method is same as to reduce the augmented matrix to row echelon form. So when we are required to find the solution of a system of linear equation by Gaussian elimination method, it's mean that first of all write the system in matrix form and then take the augmented matrix and reduce the augmented matrix to row echelon form. This will be the first step of the procedure of Gaussian elimination method. And at the second stage, find the solution of the system which we will obtain from the echelon form by using back substitution. Find the solution from that echelon form of the augmented matrix. This is the augmented matrix and this is the echelon form. So at the first stage, write the system in equation form and take the augmented matrix and then convert the augmented matrix to row echelon form. This is the augmented matrix and this is the row echelon form of the augmented matrix. And at this stage, use at the second step, use back substitution, find the solution from this echelon form. Now let's move. For example, suppose we have system of three equations: x minus y plus z is equal to 8 and 2x plus 3y minus z is equal to minus 2 and 3x minus 2y is minus 9z is equal to 9. Dear students, this system with one unique solution. This system has unique one solution, and at the end you will see that this system has a unique solution. How we can identify that this system has a unique solution? Let's see. I will tell you about that, the point from which we can identify that the system has unique solution or infinite many solution or no solution. First of all, write this system in matrix form and take the augmented matrix. This is the coefficient matrix and this is the constant matrix. So this full matrix called augmented matrix. Now perform row operations to convert this augmented matrix to echelon form. So this is the augmented matrix, and now subtract 2 times of R1 from R2. We obtain 1 minus 1, 1, 8, 0, 5, minus 3, minus 18. Multiplied this first row to 2 and subtract from R2. 2 under 2, 2 minus 2, 0. 2 under 2, minus 2. 3 minus minus 2 is equal to 5. And 2 under 2, minus 1, minus 2, minus 3. 2 8 the 16. Minus 2 minus 16 is equal to minus 18. Now multiplied this third row to 3 and then subtract the result from R2. Subtract 3 times of R1 from R3. 3 1 the 3, 3 minus 3, 0. 3 1 the 3 minus 3. Minus 3 plus 3, which is equal to 1. And 3 1 the 3 minus 9 minus 3 minus 12. And 3 8 the 24. 9 minus 24 is equal to minus 15. Now for the echelon form, we need 1 1 8 the diagonal. So for this purpose, interchange the second row and the third row. We obtain the similar matrix as 1 minus 1 1 8, 0 1 minus 12 minus 15, 0 5 minus 3. Now subtract 5 times of R2 from R3. Multiply this R2 to 5 and then subtract the result from R3. 5 multiplied 0, 0, 0 minus 0 is it is, and 5 on the 5, 5 minus 5 is equal to 0, and 5 12 the 5 to the 10 minus 60, and 3 minus 60 plus 60 we obtain 57, and similarly at this bottom we obtain 57. Now for the echelon form, this entry will be 1. So multiplying this third row by 1 over 27, we obtain 0, 0, 1 and 1. So dear students, this is the echelon form of this augmented matrix. Now note here, the rank of this matrix A is 3. There are 3 non-zero rows. So the rank of this matrix A is 3, and the rank of full matrix, if these two entry zeros, then the rank of A will be 2, and the rank of full matrix also will be 2. But if this number 0, then the rank of A will be 2, and this number non-zero, then the rank of the augmented matrix will be 3. But here this number is non-zero, so all row are non-zero in the matrix A. So the rank of the matrix A is 3, and the rank of the full matrix, augmented matrix, is also 3, and there are 3 unknown. So the rank of matrix A is equal to rank of augmented matrix, which is equal to the number of unknown. So this system has a unique solution. Now, as I have already told you in the procedures, that when we obtain the echelon form, then write this matrix again in the system form. We obtain x minus y plus z is equal to 8, and y minus 12z is equal to minus 15, and z is equal to 1. Now using the back substitution, we obtain the value of z is 1, and putting the value of z in this equation, and after simplification we obtain the value of y minus 3, and putting the value of y and z in this equation, we obtain the value of z is 1. So this system has a unique solution. Now let's move another example, system with one unique solution. Again, I want to tell you about the unique solution for a system of linear equation. This is a linear system of linear equation. x1 plus x2 plus 2x3 is equal to 8, minus x1 minus 2x2 plus 3x3 is equal to 1, and 3x1 minus 7x2 plus 4x3 is equal to 10. First of all, write this system in matrix form. This is the matrix form. A is the matrix of coefficients, X is the matrix of unknown, and B is the matrix of constant. So AX, this is matrix A, this is matrix X, and this is matrix B. Now take the augmented matrix from this system. This is the augmented matrix. Augmented matrix obtain two matrices. One matrix is the coefficient matrix, and other matrix is the constant matrix. So this is the augmented matrix. Now for the solution of the system by Gaussian elimination method, convert this augmented matrix to row echelon form by using row operations, elementary row operations. So add R1 plus R1 plus R2, first row add to R2, and R1 subtract 3 times of R1 from R3. This is the augmented matrix. So multiply the first row to R3, and then subtract the result from R3 and add first row to the second row. We obtain this new matrix, similar matrix: 1 1 2 8, 0 minus 1 5 9, and 0 minus 10 minus 2 minus 14. Now multiplying this second row by negative by minus, so 0 1 minus 5 minus 9, and now multiplying the second row to 10 and add the result with the R3. 10 times of R2 add to R3. But first of all, multiplying the second row with minus. This row containing the entries 0 1 minus 5 and minus 9, and then 10 times of R2 8 to R3, we obtain 0 0 minus 52 minus 1 0 4. Now multiplying third row by minus 1 over 52 to obtain in this diagonal obtain 1. So we obtain 1 1 2 8 0 1 minus 5 minus 9 0 0 1 2, and this is the echelon form. So this echelon form equivalent system of equation form is from this matrix, this echelon matrix, we obtain a system x1 plus x2 plus 2x3 is equal to 8, and x2 minus 5x3 is equal to minus 9, and x3 is equal to 2. And dear students, note that here in this matrix, the rank of matrix A is equal to the rank of the augmented matrix. This is the rank of, this is matrix A. Matrix A has 3 non-zero row, and similarly the full augmented matrix also has 3 non-zero row. So the rank of matrix A is equal to the rank of augmented matrix and equal to the number of unknown. In the given system there are 3 unknown, x1, x2 and x3. So this echelon matrix, in this echelon matrix, the rank of matrix A is equal to rank of the augmented matrix and is equal to the number of unknown. So this system also has one unique solution. So using the back substitution, we obtain the value of x3 is 2. Putting the value of x3 in this equation, we obtain 10 minus 9 is equal to 1, and the x2 value is 1. Putting the value of x2 and x3 in the first equation to obtain the value of x1, we obtain x1 is equal to minus x2 minus 2 x3 plus 8. Putting the value of x2 and x3, we obtain minus 1 minus 4 plus 8 is equal to 3. So this is the solution of the given system, x1 3, x2 1 and x3 2. Now system with infinite many solution. We have a system of 3 equation, minus x minus 2y plus z is equal to minus 1, 2x plus 3y is equal to 2, and y minus 2z is equal to 0. First of all, write the augmented matrix of this system. This is the augmented matrix, this is the coefficient matrix, and this is the constant matrix, constant of system of equation which lies in the right hand side of the system. So this is the augmented matrix. Now perform row echelon row operations to convert this augmented matrix to the echelon form. So this is the augmented matrix, and first of all, multiplying first row by minus 1, we obtain 1 2 minus 1 1. The first entry is 1. In this main diagonal we need 1 1 for the echelon form. So minus 1 minus 2 1 minus 1, multiplied this row by minus to obtain here 1. Now interchange second row and third row. In this diagonal we obtain 1 by performing this operation. 1 2 minus 1 1, 0 1 minus 2 0, and 2 3 0 2. Now multiplying the first row with 2 and subtract the result from R3. 2 times of R1 subtract from R3. 2 1 the 2, 2 minus 2 0, 2 2 to the 4, 3 minus 4 minus 1, 2 1 the 2 minus 2, 0 minus minus 2 plus 2, and similarly 2 1 the 2, 2 minus 2 0. Now add this second row to third row. We obtain 1 2 minus 1 1, 0 1 minus 2 and 0 0 1. Why we perform this operation? Because we need in this position we need 1. So for this 1, add the second row to the third row, we obtain 0 0 0. Now dear students, this is a very important point. Note the point in this echelon form. This is matrix A. After this line, this is the matrix A. So the rank of the matrix A is 2. There are 2 non-zero rows in this echelon form. So the rank of this matrix A is 2. But if this entry is non-zero, then the rank of the augmented matrix will be 3. But now here this entry is also 0, so the rank of the full matrix also 2, and there are 3 unknown. So using this statement, the rank of matrix A is equal to the rank of augmented matrix but less than the number of unknown. So in this stage, this system has so many solutions. The system has so many solutions, and the second equation we have 2 unknown. So one equation will be one variable. We have 2 unknown variables. So take one variable free. One variable will be free. Suppose z is equal to t. T is any real number. So putting z is equal to t, we obtain x is equal to 1 and y is equal to minus 3 t, and z is equal to t, 2t. So putting z is equal to t, we obtain y is equal to putting the value of z t, y is equal to 2t, and putting in this term the value of z is t and the value of y is 2t. So 4t minus t, 3t, and x is equal to 1 minus 3t. So x is equal to 1 minus 3t. This is the value of x. X is equal to 1 minus 3t. The value of y is 2t and the value of z is t. I want to tell you again. Suppose the value of z is t. We have 2 variables in this equation. So take one variable free. Consider one variable free. So suppose z is a free variable. So putting z is equal to t. T is any real number. We obtain y is equal to 2t. This is the value of 2t. 2t is the value of y and t is the value of z. Now putting in this first equation the value of z t, the value of y 2t. 2 multiplied 2t, 4t, 4t minus t, 3t. So x is equal to 1 minus 3t. The value of x is 1 minus 3t. The value of y is 2t and the value of z is t. So system has infinite so many solution because t is any real number. And this is the end of this segment. Thank you.